Okay, we're going to continue on with stoichiometry. So yesterday we took a look at sort of the basic stoichiometry stuff, going moles to moles, so one bracket, so just using the mole ratio. Today we're going to add a couple extra layers to that, so converting from grams to moles and eventually grams to grams. The first two examples I'm going to do are right from the notes, and then after that I will do a couple extra, so make sure you watch to the end here. Okay, so calculate the moles of ammonia produced with 12.0 grams of H2 and unlimited nitrogen. So first of all, you would have had this equation here. Okay, so very first step always when you see a chemical equation, what are you going to do to it? You're going to balance it. Good. So I'm going to put a 2 here, and I need a 3 there, 1 nitrogen. So it's important to balance because these large coefficients here, they're what give us the mole ratio. So it tells us how the different species compare to each other. So 1 mole of nitrogen for 3 moles of hydrogen produce 2 moles of ammonia. So we're going to take a look at the wording of this. Sometimes people get confused by the language used, so you have to get used to it. So first of all, I'm going to start by writing down what I'm given in the question underneath the equation. And that's a really good way to keep track of things. And I highly recommend you do that. So in your notes, you would copy down the equation and then write down what you know underneath it. So right away, calculate the moles of ammonia. So moles of ammonia is what you're looking for, moles question mark there. It tells you that you've got 12 grams of H2, so 12.0 grams here. Now the other part, you've got unlimited nitrogen. What that means is that you've got as much nitrogen as you need to make this reaction move forward. So you don't need to worry about the nitrogen. Basically, it just means you can kind of just ignore it. It's not going to be part of the question. You've got enough of it, so you don't need to worry about it. You do need to worry about the 12 grams. So the question is, how many moles of ammonia can be produced from 12 grams of hydrogen gas, and then you've got as much nitrogen as you want. So we're going to set up our dimensional analysis. So what are you looking for? Moles of ammonia, good, equals, what do you know? 12.0 grams of H2. Now, right away, I've got grams of H2. What is my very first step going to be? Yeah, change it into moles, and I'm going to stare at the poster, at the sign, where you can't see it, of course. In chemistry, we always work through the mole, yeah. So our very first step is going to be to convert that into moles, because I can't use the mole ratio until I'm in the unit moles. So grams of H2 on the bottom, moles of H2 on the top, and here's where it is going to be important that you specify what species that is. So that's H2 there, because you want to keep track of things. Now, I know that in 1 mole of H2, I've got 2.202 grams of H2. So where did this come from? Yeah, that came from the periodic table. Good. So now you're in moles of H2. You want to get to moles of NH3. So I need another bracket. Now, moles of H2, I'm going to cancel out. And I want to end up in moles of NH3. So that's going to go on the top. This is the mole ratio right here. That bracket is the mole ratio. I can go moles to moles. And I know that I've got 2 moles of NH3 for every 3 moles of H2. So now, let's just check our units before we move forward. Grams of H2, moles of H2, moles of H2. I'm left in moles of NH3. So my units all cancel properly. So 12.0 times 2 divided by 3 divided by 2.02, and you get an answer of 3.96 moles of NH3. Now, check your sig figs. 3 sig figs here, 3 sig figs there, you're good. Got it? Okay. Next question. So this one, calculate the mass of NH3 produced from 1.2 grams of H2 reacting with an excess of N2. So it's going to be the same equation here. So what do we have first? Let's do it the same way. So N2 plus H2 goes to NH3. Again, first step is going to be to balance that. Okay, So now we read the question carefully here. Calculate the mass of NH3. Mass is what unit? Grams. Good. So grams question mark under the ammonia here. I know that I've got 1.2 grams of H2. I've got an excess of N2, which means you do not need to worry about the N2. Again, it's not going to come into play with this. So everything looks good right now. So now we want to set up our dimensional analysis. So DA, what are you looking for? Grams of NH3 equals, what do you know? 1.2 grams of H2. Again, now, first step. I don't want that in grams. I have to get that out of grams right away. So I'm going to convert that into moles of H2. And I know that in 1 mole of H2, I've got 2.02 grams, that number coming from the periodic table. Now, I'm in moles of H2. I want to get to grams of NH3. But before I can get to grams of NH3, I have to get to moles of NH3. Okay, so you always have to go through that step. So grams to moles, moles to moles, and then eventually we'll go moles to grams, okay? So this bracket here, the middle bracket, is going to be your mole ratio when you're comparing the two different moles. So moles of H2 on the bottom, moles of NH3 on the top, ratio between them, 2 to 3. Now, if you stopped your problem right now, what unit would you be in? Yeah, you'd be in moles of NH3. You don't want moles of NH3, you want grams of NH3. So you're going to need another bracket. Now, our last bracket here, we want the moles of NH3 to cancel. It goes on the bottom. What unit goes on top? Grams of NH3. And in 1 mole of NH3, we've got 17.03 grams. And that comes from the periodic table. 1 nitrogen and 3 hydrogens added together. So you always want to double check your units here. Grams of H2, moles, 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 moles. You're in grams of NH3, which is what you want. So you can get your calculators out. And you get an answer of 6.74, but I have to remember I have only 2 sig figs, so 6.7 grams of NH3. Good? Okay, let's do another one. So, new equation. Let's use lithium chloride. Question 3, I guess. Lithium chloride plus magnesium nitrate. First step, I want you to predict the products. If I told you that this was a double displacement reaction, so double displacement, they both trade partners, how would you have this equation here? So you predict the products, so you would see them combining. So the lithium is now gonna, oh, I just waved at Mr. Piatek, by the way, that's who I was waving at. Lithium is going to hook up to the nitrate, so lithium nitrate. Now the lithium has an ionic charge of 1 positive, nitrate is 1 minus, so they bond in a 1-to-1 ratio. Magnesium is going to join up to the chlorine. Magnesium has an ionic charge of 2 positive, chlorine is 1 minus. So I'm going to need 2 chlorine atoms for every 1 magnesium. So I look at that there. What do I need to remember to do? Balance, yes. So I'm going to need a 2 here and a 2 here. And is it all balanced? Yeah, it's all balanced. Okay, so let's take a look at this. You can go multiple ways here. I could ask you anything on here. I'm going to say, how many, okay, just listen to my words because I'm not going to write the question down. How many grams of magnesium nitrate are required, so grams of magnesium nitrate are required to react exactly with 4.8 moles of lithium chloride? Okay, so this is my question. How many grams of magnesium nitrate are required to react exactly with 4.8 moles of lithium chloride? Okay, so my equation is balanced already, which is good. Don't need to worry about that. You're just going to go to your dimensional analysis. What are you looking for? Grams of magnesium nitrate. Equals, what do you know? 4.8 moles of lithium chloride. Very first step, you're in moles of lithium chloride already, so you don't need to convert that into moles, you're already in moles. So you can move on to the next step. This is in moles already, I want to get to grams of this, but before I can find the grams of magnesium nitrate, I must find the moles of magnesium nitrate. So, what unit goes on the bottom? Moles of magnesium nitrate. Oh, sorry, that was wrong. I did that on purpose just to see if you were paying attention. Yeah. So you're gonna have moles of lithium chloride on the bottom. And on the top, we're gonna have your moles of magnesium nitrate. Okay, and now I look to my balanced chemical equation to find the ratio between them. So how many moles of magnesium nitrate do I have? 1 for every 2 moles of lithium chloride. So if I stop the problem right now, I'm in moles of magnesium nitrate. I want to get to grams though, so I know I need another bracket. What unit goes on the bottom? Moles of magnesium nitrate. What unit goes on the top? Grams of magnesium nitrate. In 1 mole, how many grams do I have? Let's see, magnesium's what, 24.3, right? Plus, and then I have that plus, hold on. $148.3. Okay, so now I can work it all out. I want to double check, make sure my units all cancel, which they do, so I'm happy. And then 4.8 times 148.3 divided by 2 is 355.92 grams. But I need to take a look at sig figs. I can only have 2 sig figs in my answer. So your answer is going to, you can put a bar on top there, or you can round. So 360 grams of the magnesium nitrate would be your answer. Good. We're going to do one more example, and then we'll give you your assignment. We're going to use the same equation here because I'm lazy and I don't want to have to do another one. So looking at this, let's pick a new one, and now we're going to say, change my marker. Now we're going to say how many grams of lithium nitrate can be produced from 3.9 grams of magnesium nitrate. So now this is a grams to grams question. Sometimes before you start, it's probably a good idea to think about what you're doing here. So what's your strategy? You're in grams of magnesium nitrate. Your first step is to convert that into moles of magnesium nitrate. Once you've got moles of magnesium nitrate, you want to find moles of lithium nitrate. Once you have moles of lithium nitrate, you find grams of lithium nitrate. So, dimensional analysis, how many brackets are you going to need? 3. Yes, you're going to need 3. In my mind, you're all getting these answers right. It's really good. Well done, guys. So, let's go ahead and do it then. You're looking for grams of lithium nitrate. Equals, you know, 3.9 grams of the magnesium nitrate. First step is going to be to convert this into grams. So grams of magnesium nitrate on the top, 1 mole of magnesium nitrate on the bottom. And I already worked it out, it is 148.3. So, excuse me. If I stopped right now, I'm in moles of magnesium nitrate. So I want another bracket. So moles of magnesium nitrate goes on the bottom. I want to get rid of it. I got to find moles of lithium nitrate on the top. And the ratio between those is 2 to 1. And those numbers come from the balanced chemical equation, the large coefficients. So if I stopped right now, I'd be in moles of lithium nitrate, which I don't want. I need another bracket. I'm just going to put it down here. Now, moles of lithium nitrate go on the bottom. Grams of lithium nitrate go on the top. And in 1 mole of lithium nitrate, there are going to be 6.94 plus 14 plus 3 times 16, 68.94. 68.94 grams of lithium. So you want to make sure all your units cancel, do that, and then you're going to multiply all the tops, divide by all the bottoms. So 3.9 times 2 times 68.94 divided by 148.3 divided by 1 divided by 1. And your answer is, you can only have 2 sig figs because of what was given to you in the question. So 3.6 grams of lithium nitrate. Okay, it is really important to practice these. Even if you think, yeah, I got this, not a big deal. You got to practice them. So exercise 14 was what was assigned you yesterday. So now you can do 15, 16, and 17. That said, that's a lot of questions. That said, I will not be having a lesson tomorrow. Tomorrow will be a work period, and typically I would give you a work period after I introduce this concept because some people need some extra time with it. I'm going to be doing a Zoom meeting tomorrow. I'll post information about that on Schoology. So if you need help, that would be when you should be asking me, okay? And don't feel bad if you need help. Lots of people struggle with this concept. Okay, so that's it for today's class. Hope you're all socially distancing. Do not see people, right? Stay home. Wash your hands a lot. Okay, bye guys.